dear students, I am Dr. Shikha Pandey, Associate Professor from the Institute of Aeronautical Engineering, Hyderabad. So, from in this video lecture session, today the topic for today's discussion is the e-waste. As we have already discussed about all the solid waste, municipal solid waste, biomedical solid waste, and hazardous waste. So now we are going to discuss about the e-waste, that is electronic waste, and its characteristics and the management of e-waste in the global world, because e-waste is the largest problem in these days. So let's start this lecture with the basic definition of e-waste. Like, what is e-waste? E-waste is generally we can refer it as the electronic waste to old electrical and electronic equipment that have reached to end of their life. So this is called as e-waste. E-waste, or the electronic waste, that is old electrical and electronic equipment that have reached the end of their life, and it is the one of the fastest growing waste stream in the country. E-waste contains numerous toxic, which is, if we will not dispose it properly in an appropriate manner, it can causes environmental pollution and health hazard. Because e-waste is having a lots of toxic material in the e-waste, and today's we are totally depending on the communication technology, because and our growth is going to be increases due to that use of that modern technology, and with that modern technology some negativity is there, and that negativity is the e-waste, because today we are too much dependent on the technology system. It is a technology based world for today's, we can say that. But with the use of lots of computers, with the use of printer, with the use of TV, fridge, washing machine, all of these equipments will create some waste. That waste we call it as the e-waste or electronic waste. The waste we get it after the use of electrical substance is called as e-waste, and those electronic equipment that have reached to the end of their life is called as e-waste. That is, from that way, that is not too much useful, so we can call it as the e-waste. Now comes to the next thing, that is about it is the all discarded electronic or electrical equipments and devices. Means those things that are discarded, those device and equipment that has been discarded and that has been old, and use electronics that are intended for reuse, resale, disposal, or recycling, and it is also referred to as e-waste. And the example of e-waste are the computer, television, VCR, stereo, copier, fax machine. All these are the examples of e-waste, and it is all used electronic waste that has been intended for reuse, salvage, resale, disposal. Electronic waste is the discarded electronics or electrical equipments and devices, and the used electronics that are intended for reuse, salvage, resale, disposal, or recycling is called as e-waste. And the common examples of e-waste are the computer, television, VCR, stereos, copier, and fax machine. All these are the best example for e-waste. Like, those we are not using for at the present time, like that has been discarded, that has been electrical equipment. So we can, and we what we will do with that discarded item, we can reuse that item, or we can salvage, resell, or disposal, or recycle these items is called as e-waste. So all these equipments that we'll get after the use of some equipments, we can recycle it. And the example for e-waste are the computers, television, VCR, stereos, copiers, and fax machine. All these are the examples of e-waste. Now we are going to discuss about the composition of e-waste. Why we can say that, why we are saying that e-waste is a very harmful waste? Because the composition of e-waste is very much dangerous, and it is hazardous for the use of present generation, because e-waste has some cathode ray tubes that is generated from the TVs and plasma TV that is found in television and computer, which contains very highly dangerous heavy metal, lead, mercury, cadmium, beryllium, and brominated flame retardant. And the mobile phone and smartphones contain more than 50 different components that include base metal such as copper and tin, because one smartphone is having a lots of 50 different components, as we say. as we see that 50 different components, and these 50 different components will have very dangerous metals and very high toxic metal. An example for these 50 different components are the base metal. Base of the mobile phone will contain some metal like copper and tin, and some special metal like cobalt, antimony, and some precious metal like silver, gold, palladium. So these are the very much too much highly toxic metal is present in a mobile phone and a smartphone that have contain 50 different components, and these components are the, like, it's a base will contain some copper and tin. It has some special metal like cobalt, indium, and antimony, and some precious metals also, and these precious metal are silver, gold, and palladium. And the lithium ion battery contains about 3.5 gram of cobalt. This is very much dangerous for the present generation, and that's why we are calling this e-waste is a very hazardous waste, because this e-waste contain toxic metals, some very toxic metal. And now comes to the next point. This is about like iron and steel constitute about 50% of the waste. That followed plastic, 21% plastic is there, 30% non-ferrous metal and other constituents is there. Non-ferrous metal consists of metals like copper, aluminium, and some precious metal like silver, gold, platinum, palladium, and so on. So these 4 points is about the composition of e-waste. So first thing is that cathode ray tube, that will get from the television and computers. It contains lead, mercury, cadmium, beryllium, and brominated flame retardants. And a mobile phone have some 50 different components, and all these components is having some dangerous metals, and these metals are the copper, tin, some special metal is there, cobalt, antimony, bismuth, and precious metal like silver, gold, palladium. The lithium ion battery contained about 3.5 gram of cobalt. So only a lithium ion battery, and this lithium ion battery is, I think, in all equipments that we are using, either in video games, either in TV remote, or in AC remote, and everywhere this lithium ion battery is used. Sometimes this lithium ion battery is present in the as a cell in the baby toys also, and that is very much dangerous for the baby. And because if a child is playing with that lithium ion battery, he can put it in the mouth also. So this e-waste and all these things are very much harmful, and all e-waste contents have composition is all only heavy metals composition is there in the e-waste, because heavy metal is everywhere in the e-waste, and e-waste is generally made up of by metals only. So the iron and steel constitute about 50% of the waste, because 50% of the waste is having iron and steel. And after that, it will have 21% of plastic, 13% of non-ferrous metal, and other constituents. Non-ferrous metal consists of metals like copper, aluminium, and precious metal like silver, platinum, gold, and so on. So this is all about the composition of e-waste. Now we are going to discuss about the characteristics of e-waste, like why we are saying that e-waste is very much harmful, because e-waste contain lead and cadmium. These are very toxic metal. Lead and cadmium in the circuit board and batteries. Lead and cadmium is present in the circuit and batteries, and we have already knows that these toxic metal are carcinogenic in nature, there is cancer causing, that will cause cancer. So these are the characteristics of e-waste. And lead oxide, that is PbO2, and cadmium in the monitor of cathode ray tubes, and mercury in switches and flat screen monitors. PCB in older capacitor and transformer, PCB is there. And next one is the brominated flame retardant on print circuit board is there. And the next thing is the burning of plastic causing cables, PVC cables used for insulation, causes heavy damage to the environment with hazardous fumes and smoke. So what we will get that, like in circuit board and batteries, lead and cadmium is there, and in the cathode ray tube, CRT tubes, lead oxide and cadmium is there in the monitor of CRT. And the flat screen monitor will get mercury in switches, and PCB in old capacitor and old transformer is there. PCB is there in these instruments. And next one is the flame retardant on print circuit board. On print circuit board, brominated flame is there. and the burning of plastic casing, cables, PVC cables used for insulation cause heavy damage to the environment with hazardous fumes and smoke. So these are the characteristics of the electronic waste. Like we can say that every electronic waste, either in circuit board or in batteries, capacitor, transformer, computer screen, flat screen, cable, TV, plastic casing, PVC cable, some dangerous toxic metal is there. And dangerous toxic metal like lead and cadmium, we have already knows that these are the metal which is cancer causing, like carcinogenic in nature. Carcinogenic means like it is cancer causing, it will causes cancer. So lead and cadmium in circuit board and batteries, mercury in switches and flat, all as we know, cadmium will causes disease called as itai, and this is caused by cadmium. This disease is caused by cadmium. Lead oxide and cadmium in the monitor of cathode ray tube. Mercury in the switches of flat and screen monitor. And in the previous lecture, I have already discussed about the bad effects of all these heavy metal. So these heavy metal are very much dangerous for the today's generation, and for and many people unknowingly using these electronic waste, and unknowingly they will put it in the garbage, and it will be throwing in anywhere. So it is very much dangerous for the environment and normal human beings also, because people are not aware about the composition and characteristics of electronic waste. People don't know that how much dangerous it is highly dangerous, and it is cancer causing also. And some when people, when there any instrument will get discard will not working, they will discard it normally in their dustbin, or they will discard in open dumping. And with the open dumping, it will infect the it will enter into the groundwater and causes cancer also. Sometimes cattle will eat, and sometimes normal any human being who don't know it's a bad thing, they will use it. They will use some dangerous batteries. So these are very much dangerous, the electronic waste. Now comes to the generation of electric waste in the India, because today's world, due to our dependency on communication technology, ICTs, the electric waste generation is going to be increased too much in India, because India is now going to be technology based. So this will cause create e-waste generation because of due to dependence on electronics item. So India among top 10 city, Mumbai ranked first in generating e-waste. After that, Delhi, Bangalore, Chennai, Kolkata, Ahmedabad, Hyderabad, Pune, Surat, and Nagpur. And among the 10 largest e-waste generation state, Maharashtra is the first, and after that Tamil Nadu, Andhra Pradesh, Uttar Pradesh, West Bengal, Delhi, Karnataka, Gujarat, Madhya Pradesh, and Punjab. So this is the top 10 cities and top 10 state of generation of electronic waste in India. And in an Indian Market Research Bureau, IMRB survey on e-waste generation at sources in 2009, and that report shows that out of total e-waste volume in India, television and desktop include server comprises 68% and 27% respectively. Means mostly the e-waste in India is the most 68% of the total is the total e-waste, including television and desktop. Television and desktop means mostly waste that is generated in India are basically television and desktop computers. And we have already discussed that these CRT tubes will having a lead and cadmium composition. And now in India, top 10 largest city of generation of e-waste is the Mumbai ranked in first. After that, Delhi, Bangalore, Chennai, Kolkata, Ahmedabad, Hyderabad, Pune, Surat, and Nagpur. Means all major top metropolitan cities are contributing in the generation of e-waste, and this e-waste is very much harmful for today's generation, because mostly e-waste present in India, the composition of e-waste of Indian e-waste is like mostly it has television and desktop. Because and television and desktop, as we have already discussed, that it contains lead and cadmium, and lead and cadmium is a carcinogenic metal because it will be causing cancer. and desktop including server contains about 68% and 27% servers is there. So this is the electronic waste generation scenario in India. Like India is also producing too much electronic waste, and almost all metropolitan cities are present in the top 10 cities of the electronic waste generation. And these are the all from everywhere in the India, from all state one city is there. That means all state is producing too much waste, and we can say that top 10 largest e-waste generation states are Maharashtra, Tamil Nadu, Andhra Pradesh, Uttar Pradesh, West Bengal, Delhi, Karnataka, Gujarat, Madhya Pradesh, and Punjab. So these are the top 10 e-waste generation state. These are the means all mostly state are producing too much e-waste in India, and the research was done in Indian market on an Indian market by and that in the 2009, and that research reported that mostly e-waste generated in India is the televisions and desktop, and 68% of the total e-waste is the television and desktop, and television and desktop contains CRT tube, cathode ray tube, and the composition of CRT tubes is the lead and cadmium. And as we have already discussed that lead and cadmium is a carcinogenic metal. Now comes to the next thing about the electronic waste generation. India is one of the largest waste importing countries in the world. It generates about 35,000 tons of electronic waste every year and imports about 50,000 tons. And the more than 90% of the e-waste generated in the country end up in the unorganized market for recycling and disposal. This is the main thing about the e-waste generation, is like it will end up in an unorganized market where laborers are there, they don't know about the harmful effect of that particular e-waste. And the unorganized sector mainly consists of urban slums of the metro, mini metro, where recycling operations are carried out by unskilled employees using the most rudimentary method to reduce the cost. Like that, the unorganized sector in India, because India, in many people, they are very layman kind of people. They don't know about the bad effect of that e-waste. So that unorganized sector consists of urban slums. Slum is there, and the metros and mini metros where recycling generation are carried out by the unskilled employees that will result in the most rudimentary method to reduce the cost. They are using the rudimentary method, like the ancient kind of method to reduce for the recycling. And due to that thing, they are getting infected with lots of disease, and unknowingly they don't know they are exposing to that much dangerous substances, that much dangerous things. So the unorganized sector in India is a very much dangerous for the e-waste generation in the country. And for recycling and disposal, more than 90% of the e-waste generated in India is disposed of in an unorganized market for recycling and disposal. And the unorganized sector mainly consists of the urban slums of the metros, mini metros, where recycling generation are carried out by unskilled employees, because they don't know about the harmful effect of that e-waste, so that they can do it by the way they know. They are doing by their own method. They are not using proper hand gloves, they are not using proper shoes, they are not using proper dress for the safety with that hazardous substances, and they are exposing normally with these kind of metals, and they are getting very much dangerous diseases also. And we, as we have already knows in the news, sometime we'll see that some radioactive substance will found in the slum of any of a Delhi. Sometimes in a garbage we'll see that some palladium is there, some radioactive substances is there in the garbage kind of thing. So this is the due to this unorganized behavior, unorganized dumping of this e-waste in India. That's why this e-waste is very much dangerous for the Indian people, because in our country, any person, if they will their electronic item is old, they will throw it out in any slum area, or they will throw it out, and they will do by recycling by their own method. They are not using some industrial method, they are not using some technology based method, and protection is there for that recycling of e-waste generation. So this is very much harmful for the laborers and human beings and the environment also. Now comes to the next slide. This is the scenario of e-waste generation in the global market. Like It is estimated that more than 50 metric tons of e-waste is generated globally. Every year, 50 metric tons of e-waste is generated. And the report of the United Nations predicted that by the end of 2020, e-waste from old computers jumps to 400% on 2007 levels in China and by 500% in India. And additionally, e-waste from discarded mobile phones would be about 7 times more than higher than 2007 level in China. And in India, 18 times higher by 2020. So India is also coming, not competing with the developed countries also in the e-waste generation. China already produces about 2.3 million tons of e-waste domestically, second only to the US with with about 3 million tons. And such prediction highlights the urgent needs to address the problems of e-waste in developing countries like India, where the collection and management of e-waste and the recycling process is yet to be properly regulated. So, the reports of United Nations predicted that by the end of 2020, e-waste from the old computers it jumps by 400% on 2007 levels in China and 500% in the India. So, means the mainly e-waste that is producing today is the old computers, old computers, mobile phones, mobile phones, and the additional e-waste from discarded mobile phone would be about 7 times higher than 2007 levels in China, and in India 18 times higher by 2020. China already produces about 2.3 million tons of e-waste domestically, second only to the US with about 3 million tons. Such prediction highlights the urgent needs to address the problem of e-waste in developing countries like India, where the collection and management of e-waste and the recycling process is yet to be properly regulated. Because in India, the as we have already said that in India, e-waste recycling is done by unskilled manner. Unskilled laborers are doing the recycling process of e-waste. So, and India is generation of e-waste in India is already it is competing the developed nation, like it is competing in the US and China in the production of e-waste in the mostly the mobile phones and old computers. E-waste in developing countries like India, such predictions highlights the urgent needs to address the problem of e-waste in developing countries like India, where the collection and management of e-waste and the recycling process is yet to be properly regulated. And China is already produces about 2.3 million tons of e-waste domestically, second only to the US with about 3 million tons. And e-waste from discarded mobile phones would be about 7 times higher than 2007 levels in China, and in India 18 times higher by 2020. So the e-waste from the mobile phones is increasing by 18 times by 2020, and China already produces about 2.3 million tons of e-waste domestically, second only to the US with about 3 million tons. And such prediction highlight the urgent need to address the problem of e-waste in developing countries like India, where the collection and management of e-waste and the recycling process is yet to be properly regulated. So this is about the generation of e-waste in India. India, because why it is a health concern and health hazard related with the e-waste. So generation of e-waste in 2012 in India is 8 lakh tons, and annual growth rate of e-waste generation is 10%. So now we are going to discuss about the environmental concern and health hazard related with the e-waste. Why this e-waste is very much harmful. So the generation of e-waste in 2012 in India is 8 lakh tons. 2012 is 8 lakh tons, and the annual growth rate of e-waste generation is 10%. Like 10% of e-waste is increasing annually. Annually, the growth of e-waste generation is 10%, and e-waste is a highly complex to handle. As we have already discussed about the composition of e-waste, and it's a characteristics of e-waste, like it is very complex to handle, and pollutants and their occurrence in waste electrical and electronic equipments pollutants are there, and their occurrence in waste electrical and electronic equipments is there. Now, the step-by-step process of e-waste recycling. How to do this e-waste recycling? And the recycling of electronic waste is an often challenging activity. This is because e-scrap are typically sophisticated and manufactured from diverse elements like metal, plastic, and glass. It has a composition of metals, plastic, and glass. These are the basic composition of e-waste. That's why the recycling of e-waste is very tough and sophisticated, because it is manufactured from diverse elements like metal, plastic, and glass, and the process often varies. This is a general process of the e-waste recycling. So the general process of e-waste recycling, first step is the collecting and transporting. First step is to collect the e-waste in a proper manner and transport it to the place where it should be recycled. So it should be done by very much skill level, because handling of e-waste is very tough. It is skilled labors. And then shredding and sorting of e-waste. So sorting of e-waste, like sorting of plastic at one place, sorting of metal at one place, sorting of glasses at one place, and then it's dust extraction of its dust, and then magnetic separation step is there, and then after that water separation is there, and purification of waste stream, and then preparing recycled material for sale. So these are the basic steps involved in the e-waste recycling. It will start from the collection and then to recycling of waste to it's for sale. So these are the basic steps for the e-waste recycling. Now comes to the e-waste management rule in India. The Environment, Forest and Climate Change of MOEF and Ministry of Environment and Climate Change has made a rule on the e-waste generation, that is about rule in 2016. This new rule replaced by earlier e-waste rule, that is management and handling rule of 2011. So what this rule is saying, it includes CFL, compact fluorescent lamp, as well as other lamp with mercury and similar equipments. The rule for the first time bring producer undertake the MBT of the extended producer responsibility of EPR together with the targets. Producer has been made accountable for e-waste collection, e-waste exchange as well. Additional stakeholders included are manufacturer, dealers, refurbishment and producer responsibility organization. Compact fluorescent lamp CFL and other mercury containing lamp has been brought under the preview of these rules. Means this rule will focus on the use of CFL mercury containing lamps, and it will make a producer has been accountable for e-waste collection and e-waste exchange as well. Means those who will produce the e-waste has the responsibility to collect and exchange the e-waste also. And additional stakeholders includes the manufacturer, dealer, and then refurbisher and producer responsibility organization is there. And the basic, first of all, the new previous rule is there, e-waste management and handling rule in India in 2011, and it has been amendment in 2016 also. And in this new rule, in this new amendment, government has given the provision to include the use of CFL, complex fluorescent lamp, as well as other lamp with mercury and similar equipments. Rule for the first time bring producer under the ambit of extended producer responsibilities or EPR together with the targets, and the producer has been made accountable for the e-waste collection and e-waste exchange as well. Additional extent holder includes are the manufacturer, dealer, refurbisher and producer responsibilities organization. Compact fluorescent lamp CFL and other mercury containing lamp has been brought under preview of the rule. They have focused on the use of CFL tubes and CFL lamps, and the e-waste process should be a balance between disassemble, mechanical separation of complex material and metallurgical treatment. So as we have already discussed about the steps of recycling of e-waste, so now comes to the first stage of recycling of e-waste is the manual segregation of components, where different parts of e-waste are separated And the second stage is the mechanical separation. Mechanical separation of process is applied. In this process, ferrous, aluminum, plastic and non-ferrous materials are initially separated. Third stage is the plastic, and the plastics are then recycled by plastic recycling processes, which further process the plastics. And next one is the fourth stage, that is non-ferrous metals, and are sent to metallurgical treatment plant where the non-ferrous metals are separated into constituent metals. So this is about the four stage of the recycling of e-waste. First one is the manual segregation. Second one is the mechanical separation. Third stage is the recycling of plastics and further process the plastic. And fourth stage is the non-ferrous metals are sent to metallurgical treatment plant where the non-ferrous metals are separated into constituent metals. So these are the stages of recycling of e-waste, and it should be done by the skilled laborers, because if it will be handled by unskilled laborers, because e-waste is having very much dangerous metals and all unuseful and all dangerous substances. So the exposure to the e-waste should be done by a skilled person, a skilled labor only. And these are the four stages of the e-waste recycling. First one is the manual segregation of component, where different part of e-waste is separated. Second is the mechanical separation is applied. In this process, ferrous, aluminum, plastic and non-ferrous materials are initially separated. Third stage is the plastic are then recycled by plastic recycling processes, which further process the plastics. Now, fourth one is the non-ferrous metals are sent to metallurgical treatment plant where the non-ferrous metals are separated into constituent metals. Now, we are going to discuss about the pollutants that are present in the e-waste. And the first one is the arsenic. Arsenic, as we know that arsenic is the toxic heavy metal, and where it is present in the semiconductors, diode, microwave, LED lights, solar cell, etc. Next one is the barium metal, and it is present in the electron tube, fillers for plastic and rubber, lubricant additives. Cadmium is present in batteries, pigments, solder, alloy, circuit board, computer batteries. And next one is the mercury. Mercury is present in the components in the copper machines and steam irons, batteries in clocks and pocket calculator, switches, LCD also. Next dangerous metal is the nickel. Nickel is present in the alloys, batteries, relays, semiconductor, pigments, and also all etc. PCB is there. PCB is present in the transformer, capacitor, softening agents for paint, glue, and plastics. So these are the basic metals that are present in the electronic waste, and arsenic, barium, cadmium, mercury, nickel, PCB, all are the very toxic metal that are present in the electronic waste that we are going to be handled in these days. And now we are going to discuss about the treatment and disposal. Because of its very complex composition and valuable and hazardous substance, specialized, often high-tech methods are required to process e-waste in a way that maximize resource recovery and minimize potential harm to humans or the environment. First one, the treatment and disposal method that we are going to normally use in India is the first one is the landfill. Because of the complex composition of valuable and hazardous substance, specialized, often high-tech methods are required to process e-waste in a ways that maximize, in a way that will maximize resource recovery and minimize the potential harm to humans or the environment. Means the basic agenda for the disposal and treatment of e-waste is to maximize the resource recovery and minimize the potential harm. Resource recovery should be more, and the harm to humans or the environment should be less. So these are the basic agenda for the e-waste generation. So in this method, trenches are made on the flat surface by removing soil from the trenches, and waste material is buried in it, which is covered by a thick layer of soil. And in the landfilling method, trenches are made. These kind of trenches are made, and with every trenches, waste material is buried in it, which is covered by a thick layer of soil. Then a layer of e-waste is there. It should be covered by a layer of soil, thicker layer of soil. So a trenchant should be there, and soil from waste material is buried under it, and it will be covered with a thick layer of soil. And then inside the process, the degradation process in landfill are very complicated and run over a wide time span, and can be of many years, because so one or two trenches is there, and it is covered by the soil, thick layer of soil, and the process will do inside the degradation process is coming inside, working on inside the landfill. And it is very long process, because it will take many time and year to degrade this wastes. Next step for the treatment and disposal of electronic waste is the incineration. So incineration is a controlled and complete combustion process. The waste material is burned in specially designed incinerator at a very high temperature, that is 900 to 1000 degrees Celsius. 1000 degrees Celsius. This is at a very high temperature. The waste material is burned in a specially designed incinerator. And the advantage of incinerator of e-waste is the reduction of waste volume and the separation of energy content, the utilization of energy content of the combustible material. So incineration is very much useful for the e-waste, because it will reduce the waste volume. A reduction of waste volume is there. In this method, some environmentally hazard organic substances are converted into less hazardous compound substances. Now comes to the recycling of e-waste is like the fridge, washing machine, TV, monitors, CRT monitors, keyboards, laptops, modems, telephone, hard drive, floppy disk, compact disk, mobile phones, printer, CPU, memory chips, connecting wires. It can be recycled. So these are the examples of those e-waste that can be recycled. And the recycling involved dismantling, that is removal of different parts of waste containing dangerous substance like PCB, mercury, separation of plastic, removal of CRT, segregation of ferrous and non-ferrous metal, and printed circuit boards. So this is the recycling of e-waste. And in this process, all these are the examples of the e-waste that we can recycle. And it recycling involves dismantling, that is removal of different parts of waste containing dangerous substance like PCB, mercury, separation of plastic, removal of CRT, segregation of ferrous and non-ferrous metal, and printed circuit boards. It will be dismantling and removal of different parts of waste. And now on the reuse of electronic waste, it constitutes direct second-hand use or use after slight modification to the original functioning equipment. Means it constitute the direct second-hand use or use after slightly modification to the original functioning equipment. It is commonly used for electronic equipments like computer, cell phone, inkjet cartridge is also used after refilling. Old working computers can be donated to school or organization working in the field of education. Computers beyond repairs can be returned back to the manufacturers. So this is reuse of the electronic waste, and it will be minimize the harmful effects of e-waste. And now comes to the Basel Convention. Basel Convention is all about the control of transboundary movement of hazardous waste and their disposal. In 1989, a convention was made for the control of transboundary movement of hazardous waste, and this is the conference of parties of Basel Agreement is there from in 2006 to regulate the e-waste movement. E-waste export to the developing countries is governed by brutal global economics, law enforcement of environment and occupational regulation. Low labor cost should be there for the recycling and reuse of e-waste, because so less labor should be involved in this all these e-waste processes. And this meeting is also undertook to eliminate two toxic chemical group, dicophel perfluoroctonic acid plus related compounds, and the latter has been used in a wide variety of industrial and domestic applications, including non-stick cookware and food processing equipment, as well as carpet, papers, and paints. So this is all about the Basel Convention, and the Basel Convention has made rule on the inter-transboundary movement of e-waste and the e-waste recycling and e-waste reuse processes, and it should be always done by the skilled person only, and low labor should be involved in the recycling of e-waste. So recycling of e-waste is a serious global concern for lots of reasons. It has a strong bearing on our immediate environment as human and life on Earth generally. It even promises significant economic return for person, communities, and even nation also. And in developing nation, entrepreneurs are taking advantage of e-waste recycling as a steady revenue streams and advancing environmental goal. Although the steps involved might be the labor intensive, they are easy to follow from collecting and separating to preparation for sale. There are several steps involved which you can easily flow with the e-waste also. So now, thank you. This is all about the e-waste.
Like, share, and subscribe. Hit the bell icon for more updates.